students, welcome back to video lecture series for the subject Mathematics 3. Myself Dr. Ankit Acharya, and today we will discuss about very important two method. First one is a Gauss-Jacobi method to solve system of linear equation, and next one is a Gauss-Seidel method. Okay. In previous lecture in this chapter, the solution of numerical solution of system of linear equation. In previous lecture we discussed about Gauss-Elimination method and Gauss-Elimination method using partial pivoting. Okay, so in today's session we discuss about Gauss-Jacobi method and Gauss-Seidel method. Okay, so let's try to understand first of all what is the method and then try to solve some important example. Okay, so Gauss-Jacobi method. Now this method is applicable. Okay, this method is applicable to the system of equation in which leading diagonal elements of the coefficient matrix. Okay, so this diagonal elements like a11, a12, a13, these three diagonal elements are dominant. Okay, that means large in magnitude in their respective rows. Okay, so if we consider this system of linear equation, that means there are three equations and three variables. So here you can see that what is my condition, that a11, the modulus value of a11 strictly greater than modulus value of a12 plus modulus value of a13. Okay, similarly modulus value of a22, okay, modulus value of a22 strictly greater than modulus value of a21 plus modulus value of a23, and similarly modulus value of a33 strictly greater than modulus value of a31 plus modulus value of a32. Okay, if this condition is not satisfied, you cannot apply Gauss-Jacobi method. You can interchange the equation. Okay, if second condition satisfied for third equation and third condition satisfied for second equation, then you can interchange your second and third equation. Okay, similarly for first and second, first and third. Okay, so you can change the equation. So now see where a11, a12, a11, a22, a23, a33 are large as compared to other coefficient in the corresponding row. So this condition must be satisfied, right, as I explain you. Now rewriting the equation for x, y, z respectively. Here you can see that from first equation, suppose I subject x, okay, make a subject x. So b1, what is the value of x from first equation? That is b1 minus a12y minus a13z upon a11. Okay, so I just write here the value of x from the first equation. Similarly, find out the value of y from the second equation and find out the value of z from the third equation. Okay, so first you have to find out the value of x, y and z from corresponding to equation number 1, 2 and 3. Okay, so x, y and z. Now assuming x is equal to x0, y equal to y0, z equal to z0 as initial approximation and substituting in this equation. Okay, in this equation, right, in this equation. So most probably we are taking 0 as an initial approximation, right? In our case, our first approximation is always 0 in Gauss-Jacobi method. So first we assume x0, y0, z0 in example, okay, that is 0. So x1 is equal to b1. Suppose in this method, just assume that x0, y0, z0, that is our first approximation. So x1 is what? b1 minus a12. Okay, instead of right hand side in this three equation, right hand side instead of x, y, z, just take x0, y0 and z0. Okay, nothing new, right? So here you can see that these three are my first approximation, x1, y1, z1. So b1 minus a12, y0. Okay, a12, y0 minus a13, z0. Similarly, y the first approximation, call it y1. Okay, x1, y1 and z1, and right hand side instead of x0, y0, z0, just sorry, x, y, z, you have to take x0, y0, z0. So here x0, z0, or here also x0, y0. Okay, so this is my first approximation that you can see here. Okay, clear? Now again substituting this value xyz in equation 9.2, that means this in this equation, okay, the next approximation, okay, again whatever the value you will get x1 y1 z1, again you have to put all this value in this equation, right, again. So up to this, how many iteration? The above iteration process is continue until two successive approximation are nearly equal. Okay, until two successive approximations are nearly equal. So you have to continue this process until two successive approximations are nearly equal. Okay. So let's try to understand this method using one important example. Okay, here you can see that this is my example, 6x plus 2y minus z, that is equal to 4. So here you can see that 6 greater than modulus value of 2 plus modulus value of minus 1. Clearly the first condition satisfied the first equation satisfied the first condition. Now the next one is 5 greater than modulus value of 1 plus 1. So 5 greater than 2 clearly, and the modulus value of 4 greater than modulus value of 2 plus 1. Okay. So this A11 greater than A12 plus A13, this A22 greater than A21 plus A23, and this A33 greater than A31 plus A32. Okay. So definitely conditions are satisfied. So that's why now you can apply Gauss-Jacobi method. Okay. So first you have to check that all the conditions are satisfied or not. Then proceed further. Okay. Now from the first equation, the value of x, okay, that is 4 minus 2y plus z divided by 6. From the second equation, the value of y, that is 3 minus x minus z divided by 5, and from the third equation, okay, from the third equation the value of z is 27 minus 2x minus y divided by 4. Clear? Now to find out the first iteration 1, okay, iteration 1, assuming x0 equal to 0, y0 equal to 0, z0 equal to 0 as initial approximation and putting in equation number 1, okay, x0 equal to 0, y0 equal to 0, z0 equal to 0 as initial approximation. As I told you that in Gauss-Jacobi method, always we take first approximation is 0. So x0, y0, z0, 0. So right hand side, instead of x, y, z, you have to take 0. So the first approximation x1 you will get 4 by 6 clearly, y1 you will get 3 by 5, and what is your z1, that is 27 by 4. Okay, find out this value in decimal. So you will get C, 4 by 6, so 2 by 3, that is 0.67. Then y1 you will get 0.6, then z1 you will get 6.75. Now again this 3 value, okay, put in this equation number 1. Okay, the value of x1, y1, z1, put in this equation number 1. Okay, so now what is that is your second approximation. So x2 is 1 by 6, 4 minus 2 into, just I write the equation here. First of all, what is your x? X is, okay, 4 minus 2y plus z by 6. 4 minus 2y plus z by 6. Okay, what is the value of y? 3 minus x minus z by 5. 3 minus x minus z by 5. And what is your z? The value of z is 27 minus 2x minus y. 27 minus 2x minus y divided by 4. Okay, so 27 minus 2 into 0.67 minus 0.6 divided by 4, right? So now put all this 3 value in equation, okay, instead of x, y, z, right hand side. So instead of y you have to take 0.6, instead of z here you have to take 6.75. here you can see that, right? So you will get second approximation. So x2 is equal to 1.59, y2 is equal to minus 0.884, and z2 is equal to 6.265. Now here see the difference. What is the first approximation of x? 0.67, then x2 1.59. Still there are major difference. Okay, y2 and y1 0.6, and here negative value minus 0.884. So definitely you have to continue this process, right? Iteration number 3. Now x2, y2, z2. Okay, now this is my x2, this is my y2, and this is my z2. Now put this 3 value in this equation number 1. Okay, instead of xyz, right hand side. So that is your third approximation, third iteration, right? So putting x2, y2, z2 in equation number 1. So x3 is equal to 4 minus 2 minus 0.884 plus 6.265 divided by 6. So that is equal to 2.005. The value of y3, that is 3 minus 1.59 minus 6.265 divided by 5, that is minus 0.971. Z3, that is 27 minus 2 into 1.59 minus 0.0884 divided by 4. So when you calculate, you will get 6.176. And iteration 4. Okay, again still you have to further this process, because see the difference is x2 is 1.59 and what is x3? 2.005. Still we have to continue this process. Okay, so now the value of x3, the value of this 3 value x3, y3 and z3, putting in equation number 1. Okay, so x4 is equal to 4 minus 2 minus 0.971 plus 6.176 divided by 6. Sorry. So that will, you will get 2.01 by 4, that is 3 minus 2.005 minus 6.176 divided by 5. So that you will get minus 1.03, and z4, that is equal to 27 minus 2 into 2.005 minus 0.0971 divided by 4. So that is equal to 5.99. Okay, still see 2.005 and here 2.01. So the value of x is now quite near. Okay, minus 0.971, here minus 1.03. Okay, here you can see that the big difference in the value of z3 and z4, 6.176 and 5.99. Okay, iteration 5. Okay, so put the value of, okay, put the value of this x3, y3 and z3, okay, in equation number 1. So the value of x5, that is 1 by 6, 4 minus 2 into minus 1.03, okay, plus 5.99, that is equal to 2.00, y5, that is equal to 1 by 5, 3 minus 2.01 minus 5.99, that is equal to minus 1.00 approximately. Okay, and the value of z5, that is 1 by 4, 27 minus 2 into 2.01 minus 1.03, that is equal to 6.00. So since the fourth and fifth iteration values are nearly equal, okay, fourth and fifth iteration are nearly equal, you can see that here 2.01 and the value of this is 2. Okay, almost same. Here minus 1.03, here the fifth iteration is minus 1.00, here also 5.99. okay, and here 6. So now you can see that you can say that the value of x, y and z, the value of x is 2, the value of y is minus 1, okay, and the value of z is 6. Clear? If you want to check, put all this value in this 3 equation. Okay, in this 3 equation. So the value of x is what? 2 minus 1. The value of x is 2, y is minus 1, z is 6. Okay, x is 2, y is minus 1 and z is equal to 6. Okay, if you want to check that your answer is correct or not, you can easily check. Put all this value here. So 6 into 2, 12 plus okay, 12 minus 2 okay, and minus 6, right? So 12 minus 2, 10, minus 6, you will get 4. The first equation satisfied. Similarly, you can check for second equation and third equation, okay. So in today's session, just we discuss about Gauss-Jacobi method. Try to understand once again, because Gauss-Jacobi method, most important is the condition. First, you have to check that the condition must be satisfied. If these three conditions are not satisfied, then you cannot apply Gauss-Jacobi method. Okay, important. Now, next is a first iteration. First iteration, most probably we are taking 0. So x0, z0, x0, y0, and z0. This three first approximation is 0, and then we continue process until the successive approximation as nearly equal. Okay, so in Gauss-Jacobi method, make sure this some of the important thing. So up to this, thank you. Next session we will discuss about Gauss-Seidel method and solve some important example. So up to this, thank you.